We're Group 8. We are the Wireless Sensor Scavenging Network Project. I'm John Kennedy.
I'm Rustin Alt.
Rob Wayland.
Jeremy Shepard.
And Jeremy will start off telling you a little bit about our project.
Okay, like John Roy said, we are the Wireless Sensor Scavenging Network group, and a wireless sensor network, what it does is it's a deployed series of nodes that will take measurements of an environment and report them back to a centralized location, what we call the base station. What makes our project different is each of these nodes are scavenging, meaning they're not battery powered. They collect their energy from the environment they're in, whether that be through solar power, wind power, thermoelectric power, or piezoelectric power.
Just to go a little bit more in on the scavenging, we chose 4 different harvesters: a solar harvester, a thermal harvester, wind and vibration or piezoelectric. The way we designed our nodes, they will accept any of these harvesters to power the nodes and basically run them.
So we designed some software to interface with our nodes. They transmit over a Zigbee, and the idea is that eventually we'd have this sort of mesh, so a bunch of different nodes, and they would talk peer-to-peer back to our base station. Our actual software does star for the time being, but ultimately we do a peer-to-peer mesh network. And the functions of our actual software are to record all the data, the sensor data, which temperature is our default, but it could be any sensor. Preferably passive. It's to log into a database and then be able to save that to some sort of flat file. We chose XML, which is a special format version of basically a plain text file. And then we also have it so we can graph it. You can dynamically track the data by a graph window in our software package.
Okay, and one of the primary goals of our project here in the second semester was to create our own custom node. So we developed a multiple input scavenger node. It'll accept piezoelectric's AC input and rectify it. It'll accept thermal, solar, individually to power one of our microprocessing nodes. And now that we've described our project for you, we're going to show you some of our testing methods for our different harvesters, and we will show you a demonstration of our software and custom nodes. See that, right?
Mm-hmm.
You ready?
Now. You're gonna go ahead and prop the, there you go. Yeah, that's good. I'm recording, so you can turn it up, turn it down. Show the light intensity. Change.
Zoom in.
Are you good there?
So this is our software interface basically for our wireless scavenging sensor network, and here it's tracking which nodes are connected. Here we have 2 nodes. One is our node that we built with the hardware, and another one is this TI node that's using solar. Here it tracks, and the third node actually is the hub or the endpoint. Here you can see the 3 nodes that are listed. Hub 0, that's this one. Node 1, which based on the battery is probably this one, and node 2, which is that one. Here we have a grapher program, and it basically just shows the data points. Right now we're looking at hub 0's, the hub's temperature. We can switch the nodes. Here's node 2 temperature, which is, come on, 70 degrees right now. You can also switch to battery, and my favorite, signal strength, which is always terrible. And really, all there else is, there's a database here. It keeps track, it logs every data point based on the record time, which default is 10 seconds. You can change that here to be a little longer with 15 or 20 seconds, excuse me. The database, it's every point. It has the date, all the data that it's transmitting back to us through the serial port. That's how it's connected. And also the measurement ID, or basically what measurement it is. One of the nice features though is you can export this to an XML format, which is readable in various different database programs. You can also actually open this database directly through like Access or something like that. Right now this is, well, let's see. And that's pretty much it. You can change the timeout. If one of these nodes disconnects, eventually it will drop out. It will undraw it from the screen here, and it will also hide the information box. And it takes, depending on what it says. Right now it's 20 seconds, so it'll take 20 seconds now for this to drop out. And when it does, it should undraw it and hide one of these boxes. And there you go. So it's dropped out, and that shows you that you've lost a node. And the setup we have now, which is they call a star network, we would just lose the node. Ideally, it would be peer-to-peer, and we would try to, all the other nodes would try to reconnect other ways if that was another hub. That was obviously he reconnected, it came back on. And that's pretty much it.
Okay, and as for the hardware, here we have our EZ430 RF2500 solar energy harvester node by TI and Symbet. This is our MSP 430 target board that we use for all of our communications as our microprocessor on board all of our nodes. Here we were unable to fabricate our own PC board on time. Here we have our proto board with a thermal energy harvester powered node. Here's our Peltier device, and we have it simulated as being in a lunar environment. This is our heat source, our sun, and it's powering this node. We have our ultracapacitors to store the energy, and here is our energy converter. Thermal is particularly this Peltier device is very low voltage output. So here's a small transformer that steps up the voltage that allows this boost converter to charge the ultracapacitors and run our node. Anything else? Otherwise, that's cut.